All right, so today we're going to dive into the new unit all about solving equations. So if you're working with us from your packet, we're going to be reviewing the notes on page 2 through 4, and they're going to be shown up here on the board so you can kind of follow along. All right, so kind of an introduction. What is an equation? So we just spent an entire unit on expressions, which were kind of math phrases, right? An equation is what I like to refer to as a mathematical sentence. It's going to contain numbers, sometimes variables, but it's definitely a possibility. Operations are definitely going to be there, and most importantly, the characteristic of an equation is that it has an equal sign. Okay, if it doesn't have an equal sign, it's not an equation. So that's usually the characteristic we look for first to make sure that it's an equation. Now we've got two types of equations, and just like expressions here, we've got a numerical equation and we also have an algebraic equation. If you remember from the unit on expressions, the word numerical is like numbers, right? So numerical equations are going to have only numbers in here, and there's two examples. 2 plus 3 equals 5. 9 minus 2 equals 7. Now kind of dive it into those examples a little bit further. If you notice that if we look at the first one, 2 plus 3, it's kind of like the left side of my scale. Here's my equal to 5. Now again, what is on the left and what is on the right can be written many different ways. But in the end, the values need to be equal. The amount needs to be equal on both sides. So 5 is 5, right? I can't reduce that anymore. But on the left-hand side there, I have a numerical expression. 2 plus 3, if I simplified that out, I get 5. So again, the different expressions on each side of my equals can look differently, but ultimately the value is the same. That is what an equation states for us. So the second type of an equation is an algebraic equation. So again, we talk about when you start into algebra, what starts popping up? Letters, right? So again, still has characteristics of an equation, numbers, operations, definitely an equal sign, right? But now we start to see variables. Algebraic examples are here below. 4x plus 1 is equal to 14 minus 1. On the second example there, 10 minus 2x plus 7, or 10 equals negative 2x plus 7. Again, you see an equal sign, definite characteristic of an equation, and because it has letters, it is considered an algebraic equation. All right, so at the bottom of your note sheet, and again, all of you have a paper packet, so you should be following along with us. What I would like for you to do is identify the following, and again, let me see if I can enlarge it here so you can see it, as numeric, algebraic, or not an equation at all. So I'm going to go ahead and do the first three with you, the bottom three on your own. So if you take a look at the first example there, we have 10x plus 3 equals 12. Again, characteristic of an equation, I see an equal sign. So yes, it is an equation. Then ask yourself, does it have just letters? I'm sorry, just numbers, or does it also have variables? You should have chosen algebraic because it does have variables. If you take a look at the second one, again, I have an equal sign, which is a clear indication it is an equation. When I look at the terms, they're just numbers, so this would be a numerical equation. Take a look at the third one there, 14x plus 3. Is it an equation? What am I missing? I don't have an equal sign, so this would be an example of neither, so don't be tricked. Okay, if it does not have an equal sign, it's neither numeric or algebraic because it's not even an equation. So what I want you to go ahead and do is finish out those last three for me. All right, so inverse operations. When we were looking at expressions the last unit, we could evaluate them, we could simplify them. But looking at equations, we now know what an equation is, or an expression is equal to. So we are able to solve it. So equations we solve. In order to solve an equation containing a variable, again, we're looking at algebraic equations, we first have to decide what operation is acting on the variable, decide what operation is going on. So here's some poor examples here in the chart. So we're just going to practice step one. Again, looking at our problem and identifying the operation between our variable and the number with it. So first example here, I'm going to go ahead and box the side with my variable. What operation is going on between my y and my 9? Addition. Looking at example 2, again, I'm going to box the side with my variable, my x. What operation is going on between my x and my 7? Subtraction. third example here, my variable is right buddied up against that 2. When you have terms that are right up against each other like that, that is an example of multiplication. And the last example, yours actually, I believe, is fixed up in your packet, but my 10 got a little lost. Should be over here. So again, if I'm boxing up the side that has my variable, the operation between those two is division. Now, in algebraic expressions, we often see division as a fractional bar. So if you look here, we have x. Oh, that looks a little messy there. We have x and then a division bar. So x divided by 10. Yes, it looks like a fraction, but it's indicating the operation of division. All right, so there's some more practice. So down below, continuing on your chart, you should see the following problems here. So you're going to look through. If you want to box the side with a variable, you can also feel free to use operational signs. So you can put plus, minus, multiplication, division. You don't have to write out the word. But what I want you to do is to tell me, again, what operation is going on with my variable. So you're going to, and again, you don't have to box the side, but it kind of focus you in where you need to look. So I'll go ahead and do that. And again, I want you to tell me in your packet, what is the operation that you see between your number and the variable? All right, so step 2 when you're solving an equation, after you figure out what operation is going on between the variable and the number, we use inverse operations. So up here at the top, we see our chart of inverse operations. So addition is the inverse of subtraction. And you see my arrow goes both ways. Subtraction is also the inverse of addition. Multiplication is division. Division is multiplication. So when you see addition, again, we're going back to this part. If you see a problem that has the relationship of addition, we would use subtraction as the inverse. If we see subtraction, we would use addition. If you see multiplication, we're going to use division. And if we see division, we're going to use multiplication. So again, we're going to practice step 2 using inverse operations on both sides of an equation to undo it. So in my example here, I have x plus 7. Okay, so my operation between my variable and the number is addition. So my opposite is subtraction. And again, my directions tell us to name the inverse operation. What is the opposite? If I look at example 2 here, we have x minus 21. So my initial operation is subtraction. My opposite, addition. In this example, you see multiplication. So I would use division. And this last one, again, looks like a fraction, but that is how we show division in algebraic expressions. So you see division, and my opposite is multiplication. All right, so your task is to finish up the chart on page 4 here. So you're going to look first to see what operation do you see. That's your first step. What you're going to write down is your inverse operation. So it might be helpful for you to write. And again, I'll go ahead and box the part you're looking at, and you're going to tell me the opposite operation. So we're kind of following this idea. So again, if I see addition, think about what is going to be my inverse. What's the opposite of that? And so forth. So go ahead and complete those last 5. When you're finished, you can choose to either bring it in person the very next day of class to give me a chance to look at it and give you your points. Otherwise, you can also take a picture. You should be able to take 3 pictures. I really only need the charts that you were asked to complete, but in any version, I will take a picture of that work if you are a fully remote person so that I can give you credit for your assignment. Reach out if you need help, and take care.